Hello. Uh, Welcome to the third live interaction session of the course Network Security. Uh, there were no questions asked through the Google form that we have circulated. So we can discuss directly the questions in the chat window. There is one question in the chat window. Just a minute. So the question is from Weber. How many questions would be there in the exam? Could you tell what topics should be revised twice and any internships are open? We cannot disclose the number of questions in advance, but there'll be a mixture of multiple choice questions and multiple select questions. And all the topics in the course are included in the syllabus. We suggest that you revise all the topics in the course. So for internship opportunities, you can look up IIT Bombay's website where all the available internships are listed on the website from all the faculty in the institute. It is kept up to date. So the website of the internships available at IIT Bombay. So we suggest that you look up that website. So any other questions? So if you have any other questions, please ask them in the chat window. While we wait for the questions, we'll discuss some simple examples. So here's the first example. There's a user Alice who has a message, and that message is not confidential, and Alice is ready to send that message to anyone who wants the message. And thousands of people want to obtain Alice's message. Although the message is not confidential, it has to be transmitted with integrity. That is, no one should be able to modify the message during transit. So each recipient wants to be sure of the integrity of the message. So recall that we discussed a couple of techniques for achieving message integrity. One is we can attach a message authentication code to the message. The other technique we discussed was digital signature based. So if M is the message, then a message authentication code can be calculated as h of m comma s, where h is a cryptographic hash function and s is a secret key between the sender and receiver. The other technique we discussed was digital signature based integrity, where if Alice is the sender, then she calculates the digital signature as k minus of h of m, where h of m is again a hash function, and k minus is the private key of Alice. She creates a digital signature and attaches it to the message. So which one of these techniques, MAC-based or digital signature-based, is more suitable in this context? So in general, we discussed that when there is only one sender and one receiver, a MAC-based technique is more lightweight. It doesn't require any public key techniques. But here, Alice wants to broadcast the same message to thousands of people. So in this case, my claim is that a digital signature-based integrity scheme is more suitable. And the reason is the following. As we just discussed, under this digital signature-based integrity scheme, Alice just needs to send this quantity, m comma k minus of h of m, to each receiver. Alice uses a private key to calculate k minus of h of m, and every user has the public key of Alice, so they can calculate k plus of k minus of h of m and verify that that is equal to h of m, and that equals the hash of the first part of the message, that is hash of this m. So if that is true, then they can be sure that the message is has integrity. That is, it has not been modified during transit. For this scheme, each recipient only has to know the public key of Alice, and that is, we discussed different techniques for using which users can obtain the public key of a particular person. So, for example, we discussed public key infrastructure, certificates, and so on. So this scheme, digital signature-based integrity scheme, is quite simple to implement, and it is efficient in this case, where Alice wants to send the message to several users, thousands of users. In contrast, if we were to use a MAC-based scheme, then recall that in a MAC-based scheme, it is designed for one sender and one receiver, so who have a secret key in common. So if we use a MAC-based scheme, then Alice will separately need to communicate with each recipient and first agree upon an authentication key with each receiver. So if there are n receivers, then Alice needs to create an authentication key S1 with the first receiver, then S2 with the second receiver, and so on up to Sn with the nth receiver, and separately send a message with a different MAC attached to each recipient. So that is quite tedious. So it does not scale well. So hence, in this example, a digital signature-based integrity scheme is more suitable than a MAC-based scheme. Uh, okay, let's discuss another example. Uh, we discussed SSL in the video lectures. Now, suppose two users, Alice and Bob, are communicating using SSL. Uh, Suppose two SSL record blocks that are sent by Alice arrive out of order at Bob. We discussed that this typically happens in a network because different packets can take different routes to the network from the sender to the receiver. So in this example, uh, the two packets containing SSL record blocks sent by Alice, they happen to arrive out of order at Bob because they followed different routes to the network from Alice to Bob. The question is it possible for Bob to correctly reorder the blocks? Uh, so recall that in SSL record blocks, there are no sequence numbers included. So Bob cannot use SSL record block sequence numbers to reorder the blocks and put them in the correct order. So is it still possible for Bob to correctly reorder them? So uh, we uh, we recall our discussion of SSL, and we discussed that although SSL records do not have included sequence numbers, uh, but SSL record blocks are included in TCP segments, and TCP segments do have sequence numbers. So hence, it's possible for Bob to correctly reorder the blocks. This can be done using the sequence numbers of the TCP packets that encapsulate the SSL record blocks. Uh, so the receiver Bob has to just consider the TCP packets which contain the SSL record blocks and use the sequence numbers in those TCP packets. So using those sequence numbers, Bob can correctly reorder the blocks. So in this way, even though there are no sequence numbers included in the SSL blocks, Bob can correctly reorder the blocks using the TCP packet sequence numbers. So recall that sequence numbers are used in the verification of the in the verification of the MAC. So there is a MAC computed over the sequence number in SSL, but the sequence number is not actually included in the SSL record. So that's what we discussed. But this example shows that still using the sequence numbers in TCP, the recipient Bob can correctly reorder any blocks which have been delivered out of order. Uh, okay, so this concludes the discussion of the examples that I wanted to discuss. So you can ask any questions if you may have. Okay, so there are no questions in the chat window, so we'll conclude this session here. Thank you, everyone.